Hello, and welcome to the Computing Conversations column. This column is from the November 2014 issue of IEEE Computer and is titled Ian Foster and the Globus Project. There is supporting video material for this column that you can find in the IEEE Computer Society YouTube channel or in the IEEE Digital Library. I'm the editor of the column, and I'm Charles Severance from the University of Michigan. Before distributed utility computing was referred to as the cloud, it was called the grid. In the early and mid-1990s, a great deal of research focused on developing software libraries that would enable a networked cluster of low-priced personal computers and workstations to tackle large computing and storage problems that had previously required very expensive supercomputers to handle. We knew that if we could efficiently harness the power of hundreds or thousands of inexpensive computers, it would be less expensive than a single supercomputer. By the end of the 1990s, the Globus toolkit emerged as the most widely used of these software libraries that enabled distributed computing resources to be assembled into grids. I talked to Ian Foster, director of the Computation Institute and pioneer of the Globus project, about the project's early history as well as Globus's more recent work in distributed computing. The National Science Foundation Network, NSFNet, was initially intended to connect researchers to supercomputers. But the side effect was that research universities became increasingly connected both within and between campuses. It didn't take long to see that these always connected computing systems as a resource to be aggregated to solve larger problems.
I think I'm a bit of a technological determinist. I think that our innovations often occur when certain technologies are in place that can allow them to happen. Arguably the web occurred when our hard disks were big enough to store interesting numbers of images, and the networks were fast enough to communicate those images. The work we did on the grid occurred when high-speed networks were such that one could reasonably outsource computing to remote computers.
The goal was to run a standardized software suite on computing hardware from many vendors so that researchers could connect up and just use whatever computing resources they needed, much like the power grid. In the early days, the challenge was the diversity of hardware and operating systems we were running. Given that TCP/IP networking was still a relatively innovation in the 1990s, each operating system had its quirks.
It was done either on these workstations, which are of course somewhat underpowered, very underpowered relative to today, and then various so-called supercomputers at different locations, each of which was quite different than any other in its operating system and operating environment. So one ended up spending a lot of time negotiating the vagaries of the different network protocols and operating systems that existed. So a lot of the work we did in grid computing in the early days was working out how to connect things together, how to federate computers at 10 or 100 or 1,000 different locations.
As networking, operating systems, connectivity, and hardware technologies evolved in the early 2000s, the Globus toolkit went through several iterations. It was successful both in handling distributed computing and in managing data to and from many different sources. While Globus continues to be used on dedicated hardware, it's increasingly used to provide cloud-based software-as-a-service offerings for scientific storage and computation using commodity-based cloud infrastructure.
What's happened over the last 5 years in particular has been this notion of computing as a utility has really been effectively monetized, commercialized by the likes of Amazon and Microsoft and so forth, which is very exciting. What I'm interested in particular right now is how do we leverage this new cloud computing paradigm to accelerate discovery in the sciences.
While Globus still offers a set of software you can download and install on your particular computer, you can also access hosted Globus services over the network, just like many commercial cloud services. The cloud services offering was initially called Globus Online, but it's now simply called Globus. The first service that was deployed in this manner was Globus Transfer, which built on the highly successful and reliable grid FTP capabilities from the Globus toolkit.
We decided if we're going to work out how to outsource activities to the cloud, we should start with something very mundane and simple that no one or very few people want to be concerned with. So we decided to take on this task of data movement, because it ended up being one of the most important uses of Globus was simply managing the movement of data between the many nodes of a computing grid or a research collaboration, moving data from a scientific instrument like a genome sequencing machine to an analysis computer and so forth.
Although this might seem to be a simple task that's suitable to services like Box or Dropbox, when you're dealing with millions of files and many terabytes of data streaming from a genome sequencer for many weeks, the problem is significantly more complex.
If you want to move data reliably and securely and rapidly from A to B, so there's complex security things to negotiate when you're dealing with supercomputer centers and genome sequencing centers. That's one thing. Secondly, if you're trying to move 100 gigabytes or a terabyte or 100 terabytes, inevitably things will fail along the way. Disk servers will get overloaded, the network will get overloaded, someone may chop a wire, there may be a power outage, any of 100 things can happen. And so one has to be able to respond to those, detect and respond to those problems. And so a lot of the logic in Globus transfer, as we call it, is about detecting and responding to those sorts of problems. We have protocols that can restart transfers where they left off. We have restart markers built into our protocol so we can detect how far we've got at any one point in time. It's technically fascinating, but it's something that's like plumbing. You want it to work.
Ultimately, Globus is sophisticated plumbing that ensures the reliable transfer of a few terabytes of data from one source to another. Its reliability in the face of any number of network or server problems is critical. But while building scalable and reliable data transfers is an interesting computer science problem, the real goal is to advance science research.
Why are we interested in moving data? It's because we want to accelerate discovery processes that depend on many other things, not just moving data, but computing on that data, discovering it, allowing people to collaborate around the processes that will take data and turn it into knowledge. So I think the opportunities that we're starting to explore now are how do we outsource many of those activities to cloud computing resources as well. So that's, I think, where the excitement lies in the future.
Commodity networking and computing infrastructure has helped Globus move up the value chain and has reduced the effort required to participate in distributed collaborative science. But there's still more to be done to improve the efficiency of scientific collaboration.
As you start to do that, start to explore those problems, and you're starting to look at how may the processes of science itself, the processes of discovery, change. Do we end up in a more collaborative, collective, big science approach to more problems? Problems not just in the physical and biological sciences, but also in the social sciences.
As the Globus project approaches 2 decades of research in distributed computing, it continues to make use of the latest technologies and focus on using technology to advance scientific discovery. This column is from the November 2014 issue of IEEE Computer and is titled Ian Foster and the Globus Project. There is supporting video material for this column that you can find in the IEEE Computer Society YouTube channel or in the IEEE Digital Library. I'm the editor of the column, and I'm Charles Severance from the University of Michigan.